I'm Anil Kumar, and in this video we will try to understand how a reciprocal of a function is related with the function itself. So the question here is, for each function determine the domain and range, intercepts, positive negative intervals, and intervals of increase and decrease. Use this information to sketch graph of the function and its reciprocal. So I've written all the characteristics on the side, and I'll be kind of expanding on these characteristics since I feel that to draw a reciprocal of a function we need to know much more than the characteristics which we have mentioned there, especially the points where the value of the function is 1 or minus 1. So I've added them in my characteristics. So I'll take examples one by one in different videos. Let's start with linear functions. So to start with, let me write down a function as y equals to, let us say 2x minus let us say 6, right? Now if I have a function 2x minus 6, I know that its y-intercept is minus 6 and slope is positive 2. So I'll sketch the function here first. So I'm using the space. It is very less space to discuss all the characteristics, but I think we'll make a good use of this space and do something meaningful. So on this graph, if I draw line y equals to 2x minus 6, it really means that the y-intercept is minus 6 and the slope is 2. I can find the x-intercept, which should be, if y is 0, bringing 6 here divided by 2 as 3. So somewhere here, for example. So connecting these with a straight line will give me equation of the line y equals to 2x minus 6. So let us assume that this point is minus 6 for us and this point should be 3 for us, correct? So that is the x-axis, and here we have y value. Now we will study domain range. For a line, all real numbers is domain range. X-intercept we know in this case is 3, y-intercept is minus 6, positive and negative. This line is positive after x is equals to 3. So let me write down the characteristics on the side. Domain is x belongs to real numbers, range is x belongs to real numbers, x-intercept is at x equals to 3, y-intercept is at y equals to minus 6. It is positive in the interval from 3 to infinity, okay. It is negative from minus infinity to 3. The x values you have to write. Increasing, it is increasing from minus infinity to plus infinity. It is never decreasing, right? It is never decreasing. And for me, the important points are, when is it 1 or minus 1, correct? Now, if I write f as 1, then the value should be 1 plus 6 is 7, and 7 divided by 2 is 3.5. So it is 1 at 3.5. So let me say that this is, so we'll just approximate here. Let's say this point is where it is 1, and here we have this point as, let me write 3.5 here, okay? So it is 1 at 3.5, and it is, so this is, we say f of 3.5 is equals to 1, and when is it minus 1? If I write minus 1 here and bring 6 to this side, so minus 1 from 6 will be 5, and 5 divided by 2 will be 2.5. So f of 2.5 is actually equals to minus 1. So it will be minus 1 at, let us say, this point, which is 2.5, right? So these are the points where the value is 1 or minus 1. Now, so we have all the characteristics of the line. We know fairly well about it. Now it's time to understand how to use these characteristics and sketch reciprocal characteristics, right? So we know function y is this. From here, let's write down the reciprocal function now. So I'll use a different ink for that. So let's say reciprocal function r of x is equals to 1 over 2x minus 6. That becomes our reciprocal function, correct? Now Amongst these characteristics, the most important for me is the x-intercept itself. Now, this function is 0 at 3. If I write 3 here, 2 times 3 is 6, 6 minus 6 is 0. Now we cannot divide by 0, so at this point we have a vertical asymptote, right? So we have a vertical asymptote at the x-intercept of the function, right? So the reciprocal function will have vertical asymptote. So this translates to vertical asymptote. Do you see that? And since we have a vertical asymptote here, it will not be in the domain of the function, correct? So now we have a domain. So we say domain of our reciprocal function is x belongs to real numbers, but x is not equal to the x-intercept 3. Okay, so that is one thing which we get as a relation between domain and x-intercept. Now, another important point for me is, as I said, in 1 and plus minus 1. So what is the reciprocal of 1? So if I write 3.5 here, right, so what do I get? Or if I write 2.5, I'll get minus 1. So here you will notice that at these points, so r of 3.5 is also 1 and r of 2.5 is also minus 1. R is this reciprocal function. So these are called invariant points. So these points will be common to both the graphs. So I'm making them as invariant points. Now, let us look into the characteristics, the end behavior. If you see the function is becoming larger and larger, if the value of the function is becoming larger and larger, then the reciprocal should become smaller and smaller. So as it becomes larger and larger, we will have smaller and smaller value. For example, if the value is 1, reciprocal of 1 is 1. If the value is 2, reciprocal of 2 will be half, right? 3, 1/3, like that. So it becomes smaller and smaller. It becomes very large, kind of infinity. It becomes approaches 0. So this part will be positive though, but it will be approaching 0. Do you understand? Reciprocal of positive will always be positive. So what we understand here, it is positive between 3 to 13. So here also we will have positive reciprocal. Negative reciprocal will be negative. So here we have negative value, right? So as it becomes higher and higher, it will become lower and lower and more negative value, correct? So that is the kind of function which we are going to get, correct? Do you see that? Negative part translates to negative part, right? As the function increases, reciprocal decreases. So increasing results into, we'll see the interval later, increasing results into decreasing in reciprocal. We will see how soon, okay? Now, let's look into the points which are between y values, which are between 0 and 1. If the y value is half, then the reciprocal will be higher, right? So if y is half, then the reciprocal of half will be 2. If y is 1/3, reciprocal will be 1, 3 times. So it is going to increase. Do you see that? So, and it will approach very large value as we approach close to 0. So that is how we can do both sides. So what we see here is that for a linear function, reciprocal is translated 1 over x. It is translated to the x-intercept. Do you see that? So that is how it is. And important points which we consider always will be the x-intercept, which translates into vertical asymptotes. The invariant points, we call them invariant, since they are common in both function and its reciprocal. Okay, let's now look also at the y-intercept. Y-intercept was minus 6. So reciprocal of minus 6 should be minus 1 over 6. So the y-intercept becomes reciprocal, right? So y-intercept here was minus 6. So here the y-intercept will be minus, because negative will remain negative, of 1 over 6. So that is how the y-intercept gets translated. Now when we have drawn all this, we can look back into range. As we can see, we are approaching 0, but we are never at 0. all other values are in the range of our function. So we can write range of the function of a reciprocal function always as y belongs to real numbers, but y is not equal to 0. So this is a common range for any reciprocal function of a polynomial, okay? That is what we will see normally as, okay? So that is how we can see how these characteristics translate. So domain in the reciprocal gets restricted. The x-intercepts are not in the domain of reciprocal function. Range is also restricted since the function, reciprocal function, approaches 0 but is never there. So y is not equal to 0 but all other values. X-intercepts of the function translate into vertical asymptotes. Y-intercepts translate to 1 reciprocal of the y-intercept. Wherever the function is positive, reciprocal is positive. If the function is negative, for example in this interval, function is negative in that interval. If the function is increasing, reciprocal is always decreasing. If you see from left to right, the reciprocal function is decreasing. It is going from close to 0 to a negatively high value in the interval minus infinity to plus 3. And from the interval 3 to infinity, it is going from a large positive value to 0. So it is always decreasing in its domain, correct? So that is how these characteristics relate to, right? So linear functions are very basic and most important to understand. I hope you have a clear idea about it. Now we'll talk about a quadratic function and see how the characteristics of a quadratic function translate when we talk about reciprocal of that function. Thank you and all the best.